Practice Exam 3, Part 7. I was saying you could perfectly legal, perfectly fine to set up for an indirect proof here, and you would assume this universal statement, right? A statement from which you can universally instantiate. And then what would you do? You would existentially instantiate first. We're going to do this anyway. I'll explain why you existentially instantiate first. Universally instantiate from this, universally instantiate from this, and you'll get a contradiction. I'm not sure what it'll be. It'll be either FA and not FA, or GA and not GA, or HA and not HA. One of those, right, will be a perfectly fine contradiction. That'll be the final step in your indirect proof. Infer this by IP, whatever those steps are, 4 through whatever, 8, 7. That's fine. That gets you home. Okay, don't have to do it that way. Let me do it the other way. This is a not A. This is a negated A form, right? I'm going to transform this into quantified form. This is not in quantified form. I'm going to transform it into quantified form so that I can use the appropriate generalization rule to get this. So not A goes to O, so this is equivalent to things of this form, dot negation, that's O form, right? Plug in the H and the F, HX, the HX and the FX, are these equivalent? Not all H's are F, some H's are not F. Yeah, if not all H's are F, then some H's are not F. Yeah, that's logically equivalent, those things mean the same. This formula, right, so when I get this, remember I'm working backwards, so I figured out that this is what I need. When I have this, I can get from there to this by, this will be just by CQN, don't know what number yet. But this one is in quantified form, so is ripe for a generalization rule. Right? I can use the generalization rule from something to get to this. Right? This is the kind of formula which I can derive by a generalization rule. And I can also figure out what the instance will be, right, working backwards again, from which I get this by UG. I look at this, I sort of do the opposite of EI, the opposite of instantiation, to get what? H, A, and not F, A. Don't know how I'm getting that, but when I have that, I can go from there to this by EG. What kind of rule is EG? Think it through. The propositional function, HX and not FX. It's true of A, the particular individual Andrew is H and not F. Therefore I infer that there is something that is H and not F. Yeah, that's always going to be true. I don't have to restrict that. EG is a non-flag rule, non-problematic rule. Easy rule. Okay, so see where the problem has gotten to? I have worked backwards to seeing that this is the particular instance I need. So now I just need to do my instantiations to get my quantifier statements, which are just these two, right? I've sort of forgotten about one. All the information in that first premise, the conjunction, is now in here. So I've got these two quantifier statements. I'm going to instantiate, do some truth functional reasoning, and get to this. Now, you must be very aware of this moment of strategy. When you have this is the hard rule before easy rule, specific application of it, EI before UI. Off that. Do EI before you do UI. If you have, amongst your premises, this is universally the case, if you're going to instantiate from quantify formulas and you've got one existential, it'll always only be one. There might be 3 or 4 universal statements, but there'll only be one existential statement. Always do existential instantiation before universal instantiation. Why? Because existential instantiation is the hard rule, right? Because when you existentially instantiate, think about what that is again. Okay, I'm instantiating, right? I'm going from quantified formula to an instance, but I'm going from what kind of quantified formula? From the existential, because it's existential instantiation. I'm going from it's true of some individual to it's true of this particular individual Andrew, right? Just like somebody trampled my strawberries. I infer from this that you trampled my strawberry patch. That's not always going to be a valid inference. Right? It doesn't follow always and forever without restrictions that if somebody trampled my strawberry patch, that it was you that trampled my strawberry patch. Right? That is the same inference from existential statement to it's true of this particular individual. We have to restrict this inference to make sure it is truth preserving. Right? That's why, just by thinking about this rule, realizing that it isn't always universally valid, which is different to what we had when we thought about what EG is. When we think it through, realize it's not universally valid, we realize it's a hard rule, so we're going to have to do the flagging restrictions. So EI, right? So I'm going to do it now. EI, what do? You delete the quantifier, replace all the matching variables with the same individual, H, A, and not, O. Okay. EI 3. A for X, I just realized that in doing the last problem, the proof, I didn't do the A for X when writing universal instantiation. Is that all I wrote? I think so. Yeah, it's two universals. You've got to write A for X as part of the, what do you? There you go. I think I'm confusing 17. Anyway, EI 13, don't worry about that. Sorry, we do that when we get to unit 17. You don't have to do that now. All right, existential instantiation from 3. So I have to write flag A, right? Because this is when I think through what it's telling me, what I'm inferring, I realize that this isn't going to be universally valid. I have to restrict this rule. I'm restricting it by writing flag A and obeying the rules for flagged letters, right? The flagged letter has to be new to the proof. Flagged letter cannot appear in the premises or the conclusion of the proof. The third one is flagged letter cannot appear outside the subproof in which it appears. We don't really use that till unit 17 and 18, which is what exam 4 is about for the Top Gun class. But we have to do EI first because if we did it the other way around, if we did universal instantiation first, so if I wrote, so I'm going to do FA hook, not GA, that's my UI on 2, but if I had done this before I existentially instantiated, I would not be able to existentially instantiate to the letter A, because when I existentially instantiate, part of the rule is writing flag A, and I have to obey the rule that the flag letter be new to the proof, which it would not be if I'd already universally instantiated to A. If I'd already gone from 2 to this one, right, A would have appeared already in the proof, A would not be new to the proof, and I'd be breaking the flag rules in writing HA and not GA, EI flag A. I would have broken the rules. I would be entitled to go HB of the individual B. Individual B is H and not G. Right? I could write B, but then I won't be able to get to the particular propositional function true of the same individual, which is what I need here. I need either HA and not FA, or HB and not FB. It's got to be the same individual. You can't existentially instantiate to this. There exists some X. Exists some one X, which is H and not F. Can't get to that with an A and a B, with an A here and a B there. It's not the same, right? If I'm even and you're odd, doesn't mean there exists some one thing which is both even and odd. Remember the introduction to these rules and how the flagging restrictions prevent us from inferring from two premises: there exist even numbers, there exist odd numbers, therefore there exists some number, some X, which is both even and odd. Right. Exactly the inference we want to block, because the premises are true, the conclusion is false. Right, so EI before UI. Got to stick to that, okay, in instantiating from premises. Right, so now it's just some truth functional reasoning, pretty straightforward. You've got a conjunction, so HA. Okay, I'm going to get this by conj, since it's a conjunction. Simp of 4, so this will be a bit cramped. I'm halfway home. Now I just need to get not FA. I'm going to get it by simplifying to get not GA, simp 4, and I've got my modus tollens to not FA, right? 5, 6, 7, 8, 9, 10, 11, 12, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this will be CP 1 to 11. CQN on 10. Right. This is modus tollens 5 and 6. 5 and 6. Conj 6 and 8. Okay, everyone see how we did that? Truth functional reasoning is pretty straightforward. Simplify these two, right? That's the negation of the consequent. I have a conditional and the negation of the consequent. I'm allowed to infer by modus tollens the negation of the antecedent. Exactly what we needed for the second conjunct. So we put them together by conj, 6 and 8, existentially generalized. So now I just anointed the proof. Oops, I forgot one. I lost a point, right? Because I didn't do it. EG from what? EG from 9. It says 10. CQN on 10, just this. That's what got me there. Now I've just anointed this. Conditional proof, steps 1 through 11, gives me my conclusion.